Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Hi guys. Welcome to our third lecture on differentiation. So on our first two videos, we looked at the introduction to differentiation. And then we looked at differentiation of various equations. Now we are moving on to the third video on differentiation, where we are looking at differentiating using the product rule. So where do we apply the product rule? That's the biggest question that we have to keep in the back of our mind, because we have to know when to use a specific rule for us to solve specific mathematical problems. Otherwise, if we are not able to pick up that in this specific problem, we need to apply this specific formula, it means that we are not able to solve any equation or any problem in mathematics. So product rule is applied when we have got functions that are multiplied. So we've got two functions that are multiplied. For example, here I've said when we've got g of x multiplied by f of x, and you're asked to differentiate this g of x and f of x, right? So this is where we apply the product rule when we've got functions of this form, right? So how do we go about differentiating? So the first thing we must keep in at the back of our minds is that we have to keep one of the equations of the function as a constant, right? So we keep one of the functions as a constant. That's what I've written here. While we differentiate the other, then we keep the second function as a constant and we differentiate the first. So in general, right, when you have got a function y is equal to g of x f of x, you differentiate this using the formula g of x. So we've kept the first function here as a constant. Then we differentiate f of x here. Plus, we now keep the second function, which is f of x, as a constant. And we differentiate g of x. So this is the formula that we use when using the product rule. Make sure that you understand this, right? So let's move now to the application part and see how this is used. Now, so we've got an example here that says differentiate the function y equal to x plus 3 plus 2 and x plus 3. So this is our function right here. So when we apply the law, right, that we've just learned about of the product rule, what we need to do is that we come, right, and we keep one function as a constant. So the first function is x plus 2 here. So as it is written on our question is x plus 2, you keep it as a constant. Then you differentiate the second function, which is x plus 3 here. So when you differentiate x plus 3, is x plus 3, right? So dy over dx of that, you're going to get 1. So that is why we have multiplied here by 1. Right? Make sure that you understand where the 1 is coming from, right? Then from there, you keep the second function as a constant, which is x plus 3, as it is in the question. Then you differentiate the first function. So x plus 2, you differentiate that, you're going to get 1. Then you simplify. So simplifying, you're going to multiply each of the first function's factor terms by 1. So you're going to get x times 1, you're going to get x, plus x times 2 times 1, you're going to get 2 plus x plus 3. Then you simplify this, you're going to get 2x plus 5 as your final answer. Make sure that you understand this. This is just simple concepts that we have got to keep in mind. So let's move on now to the second example that we have. The second example is saying differentiate, right, y equal to 2x plus 3 plus 3 multiplied by 3 x plus 1, which is this one. So as we've just done in the previous example, you come and you differentiate. So you keep the first function here as it is in the question as a constant. Then you differentiate the second one. So the derivative of d of 3x plus 1 over dx is going to give you 3. So that is why we've multiplied here by 3, right? Plus, then you keep the second function here as a constant as it is. Then you differentiate the second one, which is d 2x plus 3 over dx. This is going to give you 2, right? So that is why we've multiplied here by 2. Then you simplify, you remove the bracket, you multiply each factor in the bracket by 3. So it's 3 times 2x, you're going to get 6x. 3 multiplied by 3, you're going to get 9. 3 multiplied by 3x multiplied by 2, you're going to get 6x plus 1 multiplied by 2, you're going to get 2. So you simplify this, you're going to get 12x plus 11 as your final answer. I'm sure this is much clear and easier as well for you guys. There's nothing that is difficult. Just make sure that you apply the simple laws that we've learned about, right? Then moving on now to the third example that we have. So the third example is saying differentiate y equal to 1 minus 3x plus half of x plus 1. So it's the same principle that we apply. You keep the first one function here, which is here as it is in the question, as the constant. Then you differentiate the second one. So when you differentiate the second, derivative of 1 over 2x plus 1 is equals to half. Plus, you keep the second one here as a constant, then you differentiate the first. You're going to get minus 3. Then you simplify this, you get your final answer is minus 3x minus 5 over 2, right? So, the product rule is also used when we are dealing with trigonometric functions, right? So, when dealing with trigonometric functions, it's still the same rule that we apply. So I've got an example here that is saying y equals sine of x cos of x, right? So dy over dx, you're going to keep sine x here as a constant, right? Then you're going to differentiate the derivative of cos x is minus sine of x, plus, then you keep cos x here as a constant. Then you differentiate sine x. The derivative of sine x is cos x. Then you simplify this, you're going to get minus sine squared x plus cos squared of x as your final answer, right? So I'm hoping that this is so clear and it's also making sense to you.